Thank you for your time and thank you for staying tuned. My name is Abel, Airoboman, and I'll be presenting a project titled Increase Energy Penetration for Rural Dwellers, Solar Wheelbarrow to the Rescue. We have a rider to our topic, Universal Access to Energy, especially for rural community. Whenever we push our wheelbarrow, we push for energy so that we can light a bulb at night and also charge our mobile devices. It's a way of presentation outline, introduction. What is the problem that we have at hand? How are we solving the problem? What steps are we taking to solve the problem? What's our result and our conclusion? Introduction. Innovation and investment are interwoven in ensuring reliable and affordable power supply. Therefore, the gradual integration and penetration of renewables into the sector cannot be overemphasized. Research has shown that 85% of persons living in the world are presently without energy. Now, according to Enegati, 80% of persons living in rural areas in Africa are without electricity. It has also been revealed that 90% of people living in Nigeria, sub-Saharan Africa, does not have access to quality and affordable energy supply. Thereafter, we should note that if the primary source of energy in Nigeria, for instance, is adequately utilized to its full potential, it could outweigh the demand for the product. Our problem statement: there's poor access to electricity in the rural areas. Now, even in the rural areas, the willingness to pay for energy is very, very low. Thereafter, or consequently, children residing in these areas, they study at night using kerosene lamp, and this has its own health implication. Now, what do we do? In this project, we present a wheelbarrow with solar fittings to be used by villages for increase in penetration of energy. The idea behind this is that we visit the market, we collect your wheelbarrow, and we fabricate a panel on top your wheelbarrow so that during the day, when you are working or when you are trading, you have a wheelbarrow or you have a panel on your wheelbarrow. At night, the energy that is conserved in your charge controller or in your battery system can therefore be used to charge your phone at night and also to light your bulb. The development of the solar wheelbarrow system for the trader, the energy from the sun can thus be converted into clean energy. The beauty of this project is that it supports the SDG Goal 7, and at the same time, it also meets the 3 cardinal objectives of the ISV, which is energy, education, and enterprise. Consequent upon the above, the energy can thus be used to light a bulb at night and also charge our mobile devices during market hours and at a particular cost, thereby putting our device, which is on the right-hand side, to a productive use and supporting the 3 pillars of ISV. Our objective, therefore, we carry an assessment on the market of interest to determine the solar radiation, orientation, tilt angle, and so on. We model and size the solar panels, batteries, charge controllers. We implement the model on a standard wheelbarrow. Then we determine and evaluate the quality and quantity of energy gotten from the implemented model. Our component, our materials and method, we have a solar panel, lithium batteries, we have our DC bulb, our converters, our charge controller, our lithium BMS, at the same time, our USB output. Under our materials and method, what we did was to arrange our batteries in series and parallel to give us a 12-volt supply. Consequently, we have a 50-watt panel that was sized to give us a charging rate at a small time, and also have our display unit and our USB slots. Therefore, as a word for our mathematical modeling process flowchart, you can see that we were able to visit the site. We size our microinverter, we size our battery, we size our panel, we size our controller, and we determine the angle of what? Orientation. Correspondingly, at the end of the day, we came out with our wheelbarrow design in our AutoCAD system and our charging on our casing for our charging system and other devices. Having got this, we now went ahead to do what we call the fabrication of the panel on the wheelbarrow. As you can see, at this point in time, our panel has been fabricated on the wheelbarrow. Then we have our controllers and other devices just beneath it. Then this is our controllers and our batteries when it was opened. So that finally, we're able to come up with a product that was even supported. We got a soft grant from the Rural Electrification Agency of Nigeria. Then we have this, we have our wheelbarrow, our panel, we have our bulb, and we have our devices. Then we conclude by saying, if we push our wheelbarrow during the day, we can light a bulb at night. Our children can light a bulb, and our children now can now study in the rural areas without any health implications affecting their eyes. Now we can charge our mobile devices during our business hour without fear of it getting missing. We can also charge those of others after asking them to pay a token. This is a productive use of our products. And what else can we say? It's a lovely product that needs to go beyond the stage that we have at this moment. Conclusively, our product was able to conform with the 3 cardinal objectives of the ISV. Energy, our product was able to generate energy for villages. Education, the energy generated by our product can be used by children in the village to study during the night hour. Enterprise, our product can also be used as a means for generating funds through phone charging during market hours. At this point in time, I'm going to say thank you for listening. I'll be expecting your vote in the category that best suit my presentation. Thank you for voting for me. My name is Abel Airoboman. Thank you once more.